Hello and welcome back to another video of our beginner's guide. The good news is that we are coming closer to the end of the CSS part of our beginner's guide, but there are still some more topics that we should talk about. And one of these topics is box sizing, a really important concept in CSS because we have to understand what it actually means if we apply a width or a height to a specific element, for example, and how this is actually calculated. Let's have a look at that in this video. So how can we understand box sizing or the basic concepts behind it? Well, we'll have a look at our website, of course, so our course project or our video series project, as I would call it. And this works quite well so far, but maybe we can get some knowledge in this video, which we can add to this site to make it work even better. And we'll also have a look at this site right here. This is basically another example project, which should just help us to get an idea of what happens if we change a specific property or a specific value. As always, you can find a link to the code in the video description. Now, how do we start though? How can we get an idea about box sizing? Well, as you can imagine, I think it makes sense to have a look at some theory first. Because what is box sizing actually? Well, let's think about the following situation. We have an element, for example, and we know the box model in CSS. We talked about that throughout this series, so make sure to have a look at this video if you don't know how the box model works. And the box model has a content. And for this content, we can define right here the box height. And this content also has a width, and therefore we can define the box width. Now, the interesting thing is that whenever we specify a width, for example, let's say 100 pixels, these 100 pixels refer to the content. And what's the reason for that? Well, the reason for that is that the standard declaration that works for the box sizing is this one. It's box sizing, that's the property, content box, and that's the value that is applied. And this simply tells us that whenever we apply, as I just said, a width, for example, of 100 pixels, that the content of our box should be 100 pixels wide. So that's the first thing you have to understand. Normally, if you don't change a thing, width or height always refer to the content of our box model. But we have more actually, right? Because we also have a padding and a border. We also have a margin, but that is not relevant right here. The thing now is that you could say, hey, I define a width for my element, for example, let's again say 100 pixels, and I want to make sure that my element, so basically my content, my padding, and my border in total, is only 100 pixels wide then. Now, the problem is that with the normal standard setting, so box sizing content box, this doesn't work. Because we saw that the width and height properties always refer to the content only. The good thing is that if you want to change it, so if you want to say that this should be your box width and that this should be your box height, well, this can be changed by simply adding this declaration. So you don't write box sizing content box or nothing at all, because as I said, content box is the standard, but you simply add the border box value to the box sizing property. And because of that, you will have the behavior we can see right here. And with that, we have the theory of that first concept that we have to understand. So let's go to our example website and see how this actually works. So that's the example project. We can see we have different elements right here. Let's have a look right there maybe. I created some nested elements. So the nested element right here is the content. So that's the element we have in the middle right there. Then we have another nested element, which I called nested. I gave it the class nested. Then we have the element navigation. Then we have the body, which you can see right here. And we have, of course, HTML. That's the basic concept that we have. As I said, it's not really a website right here. It's just to make sure that we understand what we just talked about. If we change to our code, we can see in the index.html file, well, that's basically the structure we just talked about. We have body, we have the first nested element, the second nested element, and the third nested element. And we have a CSS file. As in the other videos, I only applied some general properties to make sure that our website, well, looks like that. The important thing now is that if we go down right here to content, so to our content class right here, so basically this element nested inside, that we could now play around with the width and with the box sizing. I mostly will refer to the width in this video, but of course you can also change the height of an element, but width is easier to show and I think it's the better example for you to really see what happens. Therefore, we'll mostly stick to width. Now, as I talked about width, let's add a width maybe. Let's say this should be 200 pixels and let's save that. And if we now go back, we see that in the beginning, it was just a normal block level element. And if we now reload the page, we can see that our box size decreased. And now you might say, well, of course it decreased because we specified a width of 200 pixels. But if we inspect that right here, then you can see something interesting, because we can read that the width of our box actually is not 200 pixels, it's 210 pixels. You can see it right here. And the reason is that if we go back, that we have this width of 200 applied, but only to our content, because as we just talked about in the theory part, the default box sizing value applied is content box. And therefore, if we go back to the code and now select the element right here, we can see that right here, down in the lower right part of the screen, you can see that 200 is indeed applied, but additionally, we have a border of 5 pixels. And we talk about the width only, so it's 5 pixels to the left, 5 pixels to the right. And therefore, well, we can see that our box now has a width of 210 pixels. Now, if you think back about the slides again, we saw that we can change this behavior and make sure that our box, and by that our element, only has the width that we specify. Now, to do that, we can go back right here and simply add box sizing like that. And now you already see the options right here in Visual Studio Code. We will now use border box like that. And if we now go back to the page and reload it, then we cannot see that something happened. But if we inspect it, we can now see that the size or the width of our entire element now is exactly 200 pixels. We can again check that right here, because now we see that CSS automatically reduced the width of our content to make sure that it can include the 5 pixels to the left and the 5 pixels to the right that we saw or that we defined for our border. So that's the first important concept you have to understand when you talk about box sizing, how this box sizing works and what's the difference between content box and border box. However, if we now go back to our code and maybe leave the border box for now, that's okay, and now say that our width should not be 200 pixels, but maybe 50%, and save that. We applied that percentage value already in our project, by the way. Well, what's happening now? Because if we go back to the page and reload it, now we can see that the box size changed. We now have 206.5 pixels as a width for our element right here. And now you might ask yourself, what do these 50% of width refer to? And for that, it's again time to go back to the slides and have a look at the theory behind it. Because the question is, how is the box size calculated? And our situation is kind of as the following. We have a div, I named it div1 right here, and this div1 is nested inside of another div, and another div, and another div, but that doesn't make a difference right here to get the basic problem or the basic concept that we have to think about. Because now the question is, this one right here, what is our box height? And we saw that we can define that by pixels or by percentages. And we have the box width. We can, of course, also define that using pixels or percentage values. And one important information right here, there are more values available than pixels and percentages. But for this video and to get the basic concept, I think these two values are the best ones we can use to make sure you get an easy and nice overview of the way the box size is calculated. Therefore, we talked about pixels already, so we don't have to focus onto this right now, but we'll solely focus onto the percentage calculation as we just saw it in our example. Now that's the issue, right? How is this percentage now calculated? What's the reference point for this 50% width that we just applied? Unfortunately, the answer is not a single one, as sometimes in CSS, the answer is it depends. And what does it depend on? Well, I thought that 3 rules to remember would be a good name for the following slide. Because right here, we'll have a look at 3 different, situations and how the size of our box depends on something. We'll talk about that something, of course. And if you keep that in mind, I think you really get the solid knowledge you need to really work with that. However, there are 2 disclaimers that I would like to make right here. The first disclaimer is that, as always in life, there are not only these 3 rules. There are some additional rules that you might consider in specific cases when you want to change the size of your box. So I will not talk about the details regarding that right here, because as I said, with the 3 rules we talk about, you really have the solid basic knowledge that you need. The second disclaimer is that from now on, I'll only talk about the width when I talk about changing the size of our box. The most concepts we talk about right here are also true for the height, but I simply think that working with the width makes it easier for us to understand the concepts. Therefore, I'll stick to width. So now that we talked about these disclaimers, let's have a look at the 3 rules to remember. Because the starting point is actually the following. We have an element, and this element could be nested inside of other elements. Now, how can we now specify what the 50% width, that's what we want to apply right here, depend on? So what's the value we have to use 50% from? The answer is, well, it depends. And the first thing it depends on is the position property applied to this element. Now you might say, positioning, we talked about that, right? And yes, we did. We talked about positioning to, position the elements on our page, but position also has an impact on the size of our elements. Now, let's have a look at a first easy example to get an idea of how this could work. Because we could say that this element has the following declaration applied. Position fixed. Now, if that's the case, and we use a width of 50%, then the 50% is simply calculated by using 50% of the viewport. So basically of what you can see on your screen. And that's another important thing you have to understand. You have the element where you want to change the width in our case, and there the position property is important. But then you also have the viewport in our case, and this is the so-called containing block. So the containing block simply means that the size of the element we want to change the width for in our example depends on this containing block. And the containing block in our case, or in the case of position fixed being applied to the element, is the viewport. Now I know that this can be quite confusing, and we'll have 2 more examples to see how this works, no worries. But I think now is a good point in time to jump back to our example project and simply do that. So apply position fixed to our element and see how it's calculated. So let's go back. So I'm back right here and working here in the content selector. And now I simply add position fixed, as we just talked about. So that's the element where we want to change the width for to 50%. Now let's go back to the code and reload the page. And now you can see that our element is kind of in the middle of nowhere. That's simply due to the fact that we applied position fixed. So let's add left 0 right here and go back. If we now reload the page, we can see it's at least a little bit better positioned. So now we can see that this element has a width of 310 pixels and our viewport, so what we can see right here, has a width of 620 pixels. So our element has exactly a width of 50% of the viewport. Now you might say, well, that's not the viewport, that's just the HTML element, and you're totally right. But if you now keep in mind the 310 pixels, and we now go back to our code and increase the width of the HTML element to maybe 2000 pixels, like that, and save that and go back, and now reload the page, you can now see that our element still has a width of 310 pixels because, the viewport didn't change. But the HTML element, this now has a width of 2020 pixels. including some padding right here. That's why we have 2020. The important thing is that if I now increase the viewport right here, our element also increases to, well, 50% of the width of the viewport. So that's the first important rule you can remember. If you apply position fixed to your element, then the so-called containing block, so simply the, well, element your size depends on, is the viewport. Now, if we go back right here and maybe delete width 2000 pixels, like that, because I don't think we need that, then you can say, okay, I understand that, but we have more values that we can apply to the position property. And you're totally right. So let's have a look at another example in theory first. Back on the slide, and we again have our element right here, but now we don't have position fixed, but now we have position absolute applied to this element. Now the question again is, if we want to say that this element should have a width of 50%, what is the containing block? What does this 50% width actually depend on? Well, and the containing block in this case is an ancestor, and of this ancestor, it will be the content and additionally the padding. So this basically means that we want to change the width of our element to 50%. And if we apply the position absolute declaration, then this 50% is calculated, again, based on the containing block, specifically of the content and the padding of this ancestor. And that's important to keep in mind. What's even more important to keep in mind is that we still don't know what the ancestor actually is, or which element is the ancestor. Well, and the answer is actually quite simple, because the ancestor is simply the element which has one of these values for the position properties applied. So basically the closest element which doesn't have position static being applied. I put position sticky into brackets because we didn't cover that so far throughout the series. I just wanted to make sure that you can also find position sticky right here. So that's the thing we have to keep in mind and that we have to try out right now. We need to apply position absolute to our element and then apply position absolute relative or fixed to our containing block or to the element that we want to specify as the containing block. Let's try that out. So back in the code, and the first thing we do is we should change position fixed to position absolute as we just learned it. And we can also get rid of that left 0 now, doesn't play a role. And now let's add position maybe relative right here to our nested selector. And by that, to the element with the nested class right here. If we now go back to the code and reload the page, well, we can see that the width again changed. And let's now see what exactly happened. Because we have a width of 246.5 pixels. And the element with the nested class right here has a width of 703 pixels, which is basically not twice the width we have right here for 364.5. Now let's have a closer look at that and let's go right here to the nested class right there and scroll down. Or maybe increase that a little bit. Let's see. Because here you can see how the width is actually calculated. We have 653 as the content width. And then we have a padding of 20 to the left and 20 to the right. So this means that the total width of that element with the nested class is 693 pixels. And if you now think back about the width of our content right here, this is 346.5. Well, and times 2, this is exactly 693 pixels. So exactly the content width plus the padding of the element, so of the closest ancestor, which has, in our case, the position absolute declaration applied. As I said, this also works with absolute, fixed, or sticky being applied as a value for the position property. Now, let's have another look and let's now add the position relative declaration right here to our navigation element. And let's see what happens now. If we save that and go back and reload the page, we can now see that the size here changed. We now have 371.5. And if we now go to our navigation element right here, we can see that we have 703 plus 20 plus 20, so 743 as a width. And if we go back to our content, well, you can see 371.5 times 2 is exactly the 743 that we have right here. So that's the second rule that you can remember. If you have position absolute applied to the element you want to change the size for, then the containing block for this element is the closest ancestor, which has the position property with a value different from static applied. So that was the second rule, as I said. Now let's have a look at the third rule. Again, our starting point is the element where we want to change the size, but now we have either position static or position relative applied. And now again, what's the question? What is the containing block? Well, and in this case, it's again an ancestor, but this time it's only the content of that ancestor. And now you might ask again, okay, and what is the ancestor, or what is the criterion for that ancestor to be the containing block? Well, the answer is it simply must be a block level element. So to summarize that, if you apply position static or position relative to your element, and by the way, position static is the standard or the default value, so if you don't apply the position property, then this is always true. Well, then the containing block is simply the ancestor or the closest ancestor, which is a block level element. And of this ancestor, the value that will be used as a reference is the width of the content. So that was quite a lot, but I think with that we got the basics set and you're now able to work with the box sizing in a better way. Let's now head back to our code and have a look at this third rule in practice. And then there is one last thing that I would like to show you in this video. So back in the code, and now we said that we will change our position from absolute to either relative or static. So let's say static, so I'm not adding anything right here. And we still have the width of 50% applied. So if we go back to our code now and reload the page, we can see that it almost looks like in the beginning actually of this video. But now we should understand why our content element right here has the width that it has. Because if we inspect that, we can see that the element has a width of 326.5 pixels. And if we now go right here to our nested element, I think it's this one, yes, and now go down, we can see that this has a width of 653 pixels. The important thing is that it only refers to the content as we saw it on the slide. And if we now remember back what we saw for the content element right here with 326.5 pixels, well, this is exactly 50% of the content width of the containing block, which in our case is the ancestor, which is, or the closest ancestor, which is a block level element. Now feel free to play around with the things we just talked about, because it really makes sense to practice that to get a better feeling for the different interdependencies we have right here. But as I said, with the 3 rules to remember, I think you really got a solid basis. But as I said, there is one last thing that I would like to show you. And for this last thing, we will switch to our web page right here and now focus onto this part, so onto these 2 images. And these 2 images are here in the main part and in the trip images class. Because what do I want to show you? Let's go to the code. Well, if we go down right here to main and to the images, well, then we have this width property right here. Important, we are working here in a Flexbox environment, but what I show you right here can also be applied if you're not working with Flexbox. Because I want to show you the min width and the max width properties. It's also available for the height, min height, max height, but as I said before, I will stick to the width in this video. Because what do I want to do right here? Well, we have the width of 50% applied right here. So 50%, this means 50% of the width of the, let me show you, I think it's better right here, 50% of this trip images class right here. So 50%, you can see this image is 50% and that image. That's nice. But the problem is that if I go right here, for example, I don't like that. I think the images are way too small. And this means if I would be able to specify something like, now it comes, something like a minimum width, well, this could be helpful, right? I think it is. So let's go back and let's now add right here the min width property. And let's say the min width should be, I don't know, let's say, I don't know how big this is right here. Yeah, I think 200 pixels maybe. And that's also really important. You need to have two different values for the width and for the min width, because otherwise, if you specify a width of 200 pixels and a minimum width of 300 pixels, well, I don't think this makes a lot of sense, because then only the min width will be applied. Therefore, make sure to have something like that, like 50% of the width. That's the general rule. So basically to make sure that 50% of the space available is the image. But as soon as you go below a certain minimum value in absolute pixels right here, well, then it should change. Because if we save that and go back and reload the page now, nothing changed. But if we now decrease the size, you can see that once we reach the 200 pixels, the page or the image won't get any smaller. The problem though is that we cannot see the image anymore. Therefore, that might not be the best way to do it. But we know how to solve this quickly from the last video when we talked about Flexbox, because we can simply say flex wrap right here and set it to wrap. Oops, like that. If we now save that and go back to our page and reload it, we can see that if we make it smaller, that the image is now displayed right here below, and it won't get any smaller once we reach our minimum value. Of course, and I would totally agree with you, you could say this doesn't look good right now, and we'll work on that when we talk about media queries throughout the series. No worries. For the moment, the important thing I want to show you is that with the combination of width and min width, you can make sure that your pages are a little bit more responsive already. Now there is also a max width property. Let's have a look at that maybe. Because we can also say right here that the max width, like that, should be, let's say, 500 pixels, like this. Just save that, and if we go back and reload the page, then you can see that we have our min width. Maybe unselect the inspect tool. We have our min width right here. Now we increase the size, it increases, it increases, it increases. But once we reached the 500 pixels, it won't get any bigger. The rest is, same thing true that I just said a few seconds ago, we'll fix that when we talk about media queries. The important thing here now is that by using min width, width, and max width, you can make sure with width that your elements are displayed correctly on, let's say, normal devices. You can specify that you want to keep a minimum width on smaller devices, like mobile devices, and you can also specify a max width, because our displays or our TVs are getting bigger and bigger, and you don't want to, well, increase the image size without any limits. Therefore, setting a max width for big devices also can make a lot of sense. Now we only touched at min width and max width properties right here, because the problem is that we don't only have 3 device sizes, we have multiple devices. Additionally, we don't only have the width or the height that should be changed. It could also be that you want to have, I don't know, different colors on a different device, or you want to have some elements to disappear on specific device sizes, things like that, or getting things transparent. There are a lot of different options that you have. So basically, you might want to change multiple properties depending on the device size. And this brings us to media queries. I talked about that already, and I have to repeat myself. We'll have a look at that, well, not in the next video, but in the video following the next video. And there, we'll then talk about the details behind media queries. What you can keep in mind right now is that using min width and max width gives your page a more responsive design already, but it's limited to these properties. However, as I said, we'll talk about the details in the video following the next video. And in the next video, we'll have a look at fonts. So font sizes, how we can change that, and how we can import different font styles to our website. Because I think both the font size and the font style is not perfect right now. So therefore, hope to see you in this video. Hope you now have a better understanding of box sizing in CSS. Well, and as always, thanks a lot for watching. Hope to see you in the next video. Bye.